everyone. Thank you, Jan. And first of all, I'd like to thank the organizers and the sponsors for making this possible. This is truly amazing. I personally love community-driven events. They are, less salesy, more informal, and cozy. So yeah, and I also like to thank you for attending this session, and I wish you a great stay here today. My name is Andrei, Stefanie, and I'll present you our journey on Kubernetes, how we evolved the platform, what we adopted along the way, why we made certain choices, and how we made them. So first of all, I believe most of us are engineers, right? And we're kind of on that side. Like, okay, we know that we always have to do something, always have to improve, add more things to infrastructure as code, and improve the deployment process and try out new things. I believe we enjoy trying out new things. I mean, we're at the conference about Kubernetes. And on the other side, we have the business side. Now, there might live the sales colleagues and management and so on, and they would ask things like, okay, can we deliver this? Can we deliver this yesterday? And they'd also, at some point, might come with inquiries from customers that are actually technical, like, are you running in multiple regions? How are you handling the data, and how are you securing it, and stuff like that. So what I'm proposing today is a way to come up with decisions or make decisions that kind of help in both of those aspects. So this presentation is about decision making, also about presenting some alternatives that we considered along the way for service meshes, for messaging systems and databases, or rather where to run those databases. And also, last but not least, about presenting our journey. Personally, I really like listening to people when they present their story, because even though we face similar challenges, they're also unique. And you can learn about technologies and stuff by consulting the documentation and following getting started guides and so on. But with stories, you get unique insights. Good. First of all, there are some considerations, some choices that are purely technical, right? We have like a checklist, and okay, does this do what we need? When we consider a set of technologies that we are looking for to solve a problem, basically we'll look at it and, okay, does it do what we need it to do? Can we also use it? Do we know how to use it? Can we integrate it in our process? As a side note, generally, so we have a cloud security platform, right? And sometimes prospects come to us and they have this checklist and, hey, do you do vulnerability management? And you can say no for sure if you don't do anything for that. But besides that, it's like a whole spectrum. Like, you can barely do it, or you can do it incredibly well, right? It's a spectrum. You cannot really say yes or no. So yeah. And there are also the non-functional considerations, right? What happens if you adopt the technology? What other opportunities does it open? Things like, how will the team perceive the technology? Will it create some opportunities for open source contributions and writing content and publishing that content? So here are a few ideas that helped us along the way. First of all, choose what you can use. Now, this is pretty obvious, pretty basic. Nonetheless, it's something that we should keep in mind at all times. And it helped us tremendously along the way. This is in the context of, okay, we have to build things properly, but we also have to deliver on time. We're always, or pretty much all the time, under tight schedules, and we cannot invest too much time in making everything perfect, right? And that's why sometimes you have to go with what you already know. That's on your left side. And the example here would be MySQL. It's just an example. If you need a database, it's a relational database, MySQL, you would go with that. Problem solved. However, if you don't know a technology that would address the need, you perhaps look at something that's easy to get started with. And there are two ways here that we encountered. First one is tools that have a shallow learning curve, meaning it's easy to get started with them, as opposed to steep learning curve. And one example here for us was Nats. Any of you know about Nats? It's a messaging system. It's part of CNCF, pretty nice. It was very simple to get started with. It's a pub sub, very simple to deploy, very simple to run, use, and yeah, it also supports you. It has tons and tons of features that you can enable. But at the beginning, it's very, very simple to get started with. And on the other side, we have tools that are similar to other tools that you know. And here, the example here is the Helm Secrets. That's a plugin for the Helm CLI, which basically wraps the Helm CLI and adds encryption, makes Helm aware of encryption, helps you manage secrets, as the name might suggest. All right. Another idea is to go beyond the technical aspects. Now, here, the number one thing I'd suggest is to look for opportunities to create content about the choices that you make. For example, when we started using Nats, we wrote a blog post detailing how we run it, what we liked about it, and Synadia, the company behind Nats, actually promoted our post and reached out to us, and we felt really nice. So they invited us to their community. It's a nice opportunity for branding and just to contribute back to the community. Also, look for open source contributions. For example, one of our colleagues, Aurash, he contributed back to CV Explore, that's a vulnerability management project. He basically added EPSS back to the project. And then also, adopting a technology is a good opportunity for you to, well, improve your offering. If you're a professional service provider, you gain expertise with something, then you can start selling that thing. Or if you're like us, so we have a cloud security platform, whenever we added a new service, a new technology, we made Cyscale aware of that technology and made it work for us, which basically expanded and enabled us to serve customers that also use that technology. Good, some technical choices. Now, first of all, this is our journey. This is from where we started, infrastructure-wise, until today and even beyond. Now, first of all, this is 2021. What I want to say here is that, okay, things are not perfect, but they were in that way for a reason. Basically, it didn't make sense for us to have everything perfect and all the processes and all the pipelines perfect if we didn't validate that we were building something useful, right? So we started with not so ideal setup. While preparing this presentation, so when adding the bullet points, the third one is latest tag, and basically that we were always deploying the latest images with the latest tag and using the always pull policy. And I was thinking, okay, so we still had like a development environment and a production environment, and I couldn't remember, okay, how did we actually ensure that we were deploying certain versions to the production environment, right? And then after looking through some commit history, we basically had two separate container registries, one for dev, one for prod. And whenever we wanted to deploy to production, basically we would rebuild the images, push them to the production registry, and then the production cluster would pull them. So yeah, not so ideal. Then we have, at the end of 2021, we started improving basically we wanted to focus on improving the security, observability, and reliability of the services. Again, Cyscale runs on Kubernetes, microservices. Basically, we wanted to improve the traffic within the cluster. That's the east-west traffic, right, between the services. And that's why we adopted or introduced the service mesh and a messaging system. Before that, we use Redis lists as queues. You can make them work, but they're not ideal for this use case. Yeah. Then our team started growing. From 6, we grew to 16, something like that. We had to enable everyone to deploy. Also, the number of services increased from 7 or something like that to 30. And we kind of had to invest a bit in our processes and how we do things. And this is when we moved to Azure, just to leverage the credits. We received some startup credits, also for GitHub. So we also moved to GitHub, started using a secrets management tool, Helm Secrets. I already told you, I spoiled that. And also we separated so before we had like an umbrella chart that would deploy the whole thing. Now we have a separate Helm chart for each service. And that worked better for us. Then the previous year, we focused heavily on infrastructure as code and GitOps. Basically, we wanted to be able to create new environments, to deploy in extra regions, to deploy dedicated instances for our customers, for some of them. And we needed a way to provision that in a repeatable and safe manner. So that's when we defined basically everything, and I mean everything in Terraform. We also moved to AWS mainly because we received credits from AWS. But we also used those opportunities, those migration opportunities for dogfooding purposes. So we make Cyscale work better for Cyscale because we basically understand better how to run a product on that provider. And yeah, we also introduced Argo CD for GitOps. And yeah, beyond that, we have some things that we want to do, some ideas. And yeah, so things like adding some parts of the platform. So initially we had everything in the cluster, then we started moving some things out of the cluster. But if you're running things on VMs, you can actually add VMs to a service mesh, which is quite nice. Good. How many of you are running a service mesh? Okay, so basically a brief intro. A service mesh basically helps you with security. It basically adds mutual authentication, actually mutual TLS between services. Also with traffic management, so you don't have to modify your application code in any way to add retries and timeouts and do canary deployments and A/B testing. It's quite nice. Also helped us a lot with observability. And here, as a small story, we had a service that produced lots of logs, right? And we said, okay, we have to fix this. We have to reduce the logs. And basically, we jumped to the other extreme. It wasn't producing any logs now. And we weren't even sure it was doing anything. So then we figured out that, okay, hey, we can actually look at the proxy. So a service mesh basically adds a proxy for each one of your containers, right? In the pod, there will be another container that basically intercepts all the traffic through IP tables. And basically, you can look at the logs of that proxy container and see all the traffic that your application container generates, which helped us a lot. And last but not least, also you can add non-Kubernetes workloads to a service mesh, which is quite nice. These were the options, the alternatives that we considered: Istio, Linkerd, and Open Service Mesh. This is back in 2021, remember, so I don't expect many of you to know about Open Service Mesh. Yeah, so basically it was pushed by Azure, and then they deprecated it, and they now suggest Istio or something else. As some limitations that we faced, they are still applicable today, nowadays, for the most part. So some protocols, basically a service mesh will try to figure out the protocol that your application uses. And it does that by looking at the first few bytes that your client sends. However, some protocols like MySQL and NATS, they use an approach in which the server sends the first few bytes. And basically, the service mesh will time out, and it will not be able to figure out the protocol. So what you can do is basically you can tell it, hey, just consider this to be TCP, and don't worry about it. They call them opaque ports. Then we also face some issues with the init containers, right? So we need the proxy. Remember the proxy from this slide? The sidecar proxy. However, when using init containers, there will not be a proxy yet available. And if you're using those to maybe do database migrations, those init containers will not communicate through the service mesh. So you cannot actually enforce mutual TLS in all cases. Also face some issues with the order in which containers started. So we have two containers, the app container and the proxy. If the app container starts before the proxy, then it's not going to be able to reach out to the service mesh. Both of these issues will be addressed or should be addressed by Kubernetes native sidecars. Basically, those are init containers that will run beyond the initialization phase. And also another issue that we faced, especially with Istio, was the default configuration. That's a bit, yeah. So the default configuration basically requests a bit of CPU and a bit of memory. However, that happens for each sidecar, for each proxy. And if you have 30 services, now all of a sudden you need 3 more vCPUs and 4 gigabytes of RAM. It adds up quite a lot. So you couldn't actually deploy it with the default settings. You can tune those and lower them. It's fine. And we went with Istio. Yeah, for messaging system, you already know we chose NATS. I mean, we considered the others, even though perhaps Kafka is not like ideal for what we needed. One thing that I want to mention here is to look for other opportunities, right? Those are our selection criteria. And you kind of expect them, good documentation, good clients, and so on. But there are also other opportunities. So for example, after we chose NATS, we also use cloud events. How many of you know about cloud events? Yeah, so basically they are a standard to structure messages, right? To add some metadata to messages to events, if you have an event-driven system. And of course, you need some SDKs that will help you instantiate or create structures holding the data that you want to send through an event or through a message. And there are SDKs for JavaScript, for Go, for most languages, for cloud events. And we found an opportunity to actually contribute back to the JavaScript SDK for cloud events for NATS. So each cloud event has a protocol, and NATS is one of those protocols. Also for GraphQL subscriptions, we heavily use GraphQL. So GraphQL has queries, mutations, and subscriptions. Subscriptions are basically what you would use to create notifications and real-time stuff. And you need a pub/sub mechanism for that. NATS can be that mechanism. You just need an adapter for it. And that was another opportunity. Good. For managing secrets, we'll go pretty fast through this. We considered Helm secrets, sealed secrets, and using a combination between Secret Store CSI and the services of the cloud providers. We were on Azure at this point, so we considered Azure Key Vault. We went with Helm secrets. It was the simplest. We also gave a shot to sealed secrets. Now, the project is really powerful. We just couldn't figure it out. Of course, we didn't allocate enough time to it, but we were looking for something much, much simpler. And Helm secrets helped us there. Good. Deployment-wise. Now, at this point, our services, at this point, we had 35 repositories, 35 services. And each one of them had a pipeline on GitHub Actions that were deploying the service and building the image, and However, the issue with that is, well, they can be slow when deploying, for example, to production. We still wanted to deploy certain versions, right? And we would have to run the pipeline from each service to deploy to production. And even if it takes 1 minute, if we were deploying 10 services, it would still be, a few minutes to go through each one of them. Also, what happens when we add a new cluster for a new region, for a dedicated customer, for a new environment? Basically, we would have to modify all the pipelines. And also, another consideration here is that when you do this, the pipeline needs some permissions. It needs to be able to access your cluster, right? Or it also needs to be able to fetch your secrets if you're storing them in some secrets service. While that got better over time. So for example, on Azure, you can actually use federated identity. Basically, you say that this repository with this environment can access the cluster. There are still some issues, some limitations. For example, in Azure, you are limited to 20 federated identities per service principal, so you need some mapping, and you have to do some workarounds. Good, and basically, GitOps kind of addresses all the problems, or did for us. And we, Argo CD 1. It was the only one that we considered. We already kind of knew about it, so we knew it would serve us well. What I want to add here is that what we found really nice about Argo was that it offers this dashboard. Now, of course, there are other dashboards for Kubernetes, but we use this, and it supports single sign-on. We use Google for that, also RBAC. So you have like this config map that in which you can define roles and assign permissions to users or groups. So that's quite nice. And also it was a good, so having this dashboard is a good opportunity to introduce your colleagues that are perhaps less accustomed to DevOps and all of this, to deploying services, to seeing them running, to having a rough idea of how it works. You can even deploy it, from the dashboard, deploy a service from the dashboard. Okay, we run Argo CD or deploy it through Terraform. At this point, we moved to AWS, and we use Terraform to provision everything. And we're also using ECAS Blueprints add-ons. So basically, that installs Argo for us fairly easy. And also for secrets, remember we are using Helm secrets. And at this point, we had to configure Argo to also use Helm secrets for us, because basically it was running Helm. And you can do that through an init container. Basically, on the Argo CD pod, you can configure the init container to set up Helm secrets and the backend that it uses, Vaults, for example, that kind of does with encryption and all that. And then tell Argo, hey, please use this instead of the default Helm installation. Good. This is what it looks like. You probably have seen this before or something similar. And then the last technical consideration that we'll talk about is about running databases. So the first option here is running them in the Kubernetes cluster. This is what we had at the beginning. Basically, everything was running in the cluster. And it has some benefits. First of all, having everything in the cluster means that you have everything in the cluster, and you just need a cluster to run everything, obviously. And also, since the databases and everything run in the cluster, you kind of use the same approaches for monitoring, for operations in general. And one more thing, operators and charts, especially for databases, are evolving quite a lot. They're getting pretty good, and even trivializing things like running clustered databases. So yeah, that's a big benefit that we have seen. One suggestion here is to consider dedicated nodes for running especially large databases. We use that for Neo4j. Basically, you use taints and tolerations to tell Kubernetes that, hey, this pod can only run on that node, and that node accepts only this kind of pod. One issue here that might arise is you might face some issues about the resources that you have available. We'll talk about that on the next slide. Then, of course, you have the option to use managed services. Those can be things like RDS, but they also can be things like MongoDB Atlas, for example. And a suggestion here would be to consider using an external name service. Does any of you know what an external name service is? It's a service from Kubernetes, yeah, a type of service. So yeah, basically, if your pods have to communicate to the database that's running outside of the cluster, you can have this external name service that basically points to your database. And they also can be quite pricey, but usually for a good reason, because running some of those databases can be quite intensive, let's say. And then you have, of course, the option to run them on virtual machines. And, well, here you have better resources because you can use the entire virtual machine. You also have access to what's running on the virtual machine. Of course, you still have that. You can get that on Kubernetes too. Also, another idea here is that you can add that virtual machine to a service mesh. And, of course, you have to consider the total cost of ownership. You have to set up backups. You have to set up upgrades. Somehow you have to deal with those. So consider those when you make this choice. Now, regarding, remember this point from here, this last point for running databases on Kubernetes, there is this excellent article from Dan from LearnKate. He basically looked at how much resources each cloud provider reserves for kubelet, for the operating system, from your nodes. And what he found out was that all providers reserve some, but Azure was the most aggressive. And at this point, we were also on Azure, of course. And yeah, so they reserve something for the kubelet, for the operating system, and they also have a threshold. So if your resource utilization reaches that threshold, Kubernetes will start killing your pods. And if you're running the database and only the database on that node, guess what? It will kill your database unless you have a pod disruption budget. So yeah. In our case, so again, we were running on Azure. So we were using nodes with 32 gigabytes of RAM, just to have an idea. And we could really use only about 26 gigabytes, which, okay, it's not that much, 6 gigabytes, but if you have multiple instances, it adds up. And also, if you're tuning your database, if you're telling it, hey, you have this much memory, or these many resources, you have to use the new, the actual resources that you have available. Good. And by the way, yesterday, like literally yesterday, I checked the documentation from Azure, and they relaxed those reservations, so they are now closer to the other providers. And also relaxed the threshold, which was 750, and now it's 100. Good. For running databases, for us, it made sense to choose all of them. We have multiple databases, have like 5 databases. Some of them still run on Kubernetes. We're happy with them. Moved MySQL to RDS. It was just, better from an operations point of view. And for VMs, we have some really big Neo4j instances, and we needed all the power that we could get. And that's why we moved Neo4j on VMs. By the way, here you can use AMIs or images from even the vendors themselves to ease that deployment and configuration of the database. Good. Some more tips. Here they are. I'm just going to emphasize the document your decisions, because so 3 years down the line, you'll look back on your decisions and you'd say, okay, what's this? However, at that point in time, it probably made sense for you. It was probably the right decision. You just have to remember all the context and all the priorities that you had at that point. And also, enjoy your journey. And with that being said, I thank you for your attention. I wish you all a meaningful journey in your career and your life. Thank you.
Thank you for the presentation. I believe that you migrated all your services to the new infrastructure, to the Kubernetes, not all at once, but maybe one by one. And in the beginning, I believe that all your services didn't know how to communicate with NATs and other secret services that you mentioned. How did you manage to work it well?
So we were kind of lucky that we didn't have to do this incremental migration. We just did a big bang approach and moved everything. We rehearsed quite a lot deploying to a new provider, for example, but we just, did the DNS switch, and that was it. So, but yeah, it's not perhaps what you were looking for.
Okay, thank you.
By the way, I can add here. So for NATs, for example, you have this concept of a leaf node, and leaf nodes can help you here. Basically, you have a cluster running somewhere else of NATs servers, and you can add a leaf node also on hybrid. If you're running on-prem, you can add this leaf node that basically connects to the actual cluster, and you can use that.
I have a question related to secrets. You told that you can use Helm secrets, but did you use external secrets, something like integration in order to be able to use secrets from AWS Secret Manager or something like this? in your integration?
Yes, so initially, Helm secrets used behind the scenes as a backend, that's how they call it, SOPs, that's a tool from Mozilla. And basically, the way SOPs works is it encrypts your secrets, your actual values, and store them in the repository, in the Helm chart, or where you store your values for the Helm chart. And yeah, so initially we didn't need service for storing secrets, but then we switched to the other backend, which is called vals, which enables you to no longer store the actual secrets, even if they are encrypted, but store references to other places. And those references can... Sorry? To external secret. Exactly. Exactly. Basically, part of the value from there is like ref something, AWS Secrets Manager or Azure Key Vault or something, and it will know if it will know, and if it's able to, it will fetch the secrets when you run Helm secrets upgrade. Thank you.
Okay, thank you, Andrei, for the presentation. I have a question related to the CI part. So how exactly you are handling the CI? You have templates for that. What is the approach over there? As you have moved also from GitLab to GitHub Actions.
So CI as in running the tests, or?
No. The CI part that will be the image itself, and after that we go to the CD. But the CI itself, how you are handling? You have templates, you don't have templates, you are triggering Argo in some way. So a little bit of that approach, but general, not into the details.
So we tried using GitHub templates for actions. We couldn't make them work for some reason. I don't know. I wasn't personally involved in that. I just know that it didn't work. So at this point, we are just kind of duplicating actions between services. Yeah.
And after you are okay. Thank you. And after that, you will trigger automatically Argo CD. How you are configuring Argo CD? Automatically sync every time, or you are triggering?
So for the development environment and perhaps other environments, we just run synchronize it with the head, with the main, whatever is up to the latest thing. However, for other environments, for example, the production, we have the Argo CD applications. This is how Argo knows what to deploy. Also support the version, right? And we create those Argo CD applications from Terraform. And basically, we have this file here, which basically contains, it's a map with all our services and their versions that we want to run on that environment. We update that file. It's really nice because we can update the entire file with all the services, or whichever we want to modify. And then there is a pipeline that runs in 1 minute, updates the Argo CD apps, and then Argo CD figures out that, okay, I have to synchronize those services.
Okay, nice. Thank you.
Thank you.
I saw you put really very big limits for database, 26 gigabytes. So, and you told you are using nodes with 32 gigabytes RAM memory. So, basically, when scheduler want to schedule a pod, in case here is no capacity, the scheduler just tell us that no node capacity and the cluster autoscaler should scale up nodes. How you are overcame this situation, or you just provision the nodes with reservation, or are you using as well cluster autoscaler in case there is no capacity, or what is the reason to put such big limits, 26 gigabytes in your template?
So are you referring to capacity from the cloud providers, or what capacity?
No, you have limits, resources for database pod. And I saw you used 26 memory limits. Yes. So what is the reason to use such big limits? And in case you don't have capacity and the scheduler cannot schedule this pod because it cannot reserve this 26 gigabits, and we have just situation no nodes capacity.
Yeah, I got it. So we have dedicated nodes, or had dedicated nodes. This is for Neo4j, by the way. Basically, we used dedicated nodes, dedicated node pools for Neo4j. Basically, it always had at least one node with those resources. And we also specified them here, also the requests and the limits, for having the quality of service. Do you know what quality of service? Yeah.
Thank you.